All right, hi AP Stats. This is day 2, the very ending of 8.3 notes. So the last thing we want to talk about is if we're doing a means and a confidence interval for means, and they're asking us to choose the sample size. Well, things get a little bit flaky here too, and we have a few more things to consider that we didn't have to consider in proportions, right? So usually you would set the margin of error and then set it greater than or equal to whatever the calculation is for margin of error. But we're going to have two different possibilities, right? If they give us the t star score, right, then I could use that. But what if I don't have it? So if the t star score is not given, right, and they might not give it, and I won't know sample size, and I probably won't know sample size, right? Because that's what they're asking us to solve. I probably won't know sample size to calculate degrees of freedom. Then I'm in all kinds of problems. I can't even put in 2 of these already, and I already have a major problem, right? So then all we're going to do is we're going to switch over to Z star because it's the next best closest thing. So if we can't use a T star for whatever reason and it doesn't work, we just switch back over to a Z star and don't worry so much about it, right? So that's basically what it says. So it basically says use margin of error for known standard deviation instead. So we're going to use Z star and we're going to use sigma for our population if we have it. Okay, so we're going to use sigma if we have it. Guess what we do if we don't have sigma if we have it? And then if we don't have it, we're going to just switch back over to our sample standard deviation if we don't. Okay, so when you're going forward, when you're giving all the information and you're trying to create a confidence interval, we need to be really careful about whether we're doing a Z star or T star, right? Depending on whether sigma is given or not. When we're working backwards, often we're not going to have T star, we're not going to know what the degree of freedom is, so we're going to go back to Z star and sigma if we have it and S of X if we don't, all right? So that's the main idea here. It's going to be pretty straightforward, pretty fast, all right? So let's go and do our example here. So a counselor wants to estimate the average number of text messages sent by students at his school during school hours. He wants to estimate mu at the 99% confidence level with a margin of error of at most 2 texts. So I'm circling 99 at most 2. A pilot study indicated that the number of texts sent during school hours has a standard deviation of about 9 texts. All right, how many students need to be surveyed to estimate the mean number to be within at most 2 texts? So this is usually margin of error has to be bigger than or equal to, we're going to go T star. No, we don't have it. So we're going to go Z star. And then we're looking for standard deviation of the whole population over square root of n. Or we're doing margin of error greater than or equal to Z star S of X over square root of n. Okay. So the 9 is going to go on top of that fraction no matter what, whether it was sigma or whether it was standard deviation. A pilot study indicated, right, that a number of texts sent during school hours. So I don't think the 9 texts relate directly to his sampling. I think it relates to the population. So in this case, I think we are using 9 as sigma instead. But that's okay. We're going to just plug in our numbers here. We want it to be within 2 texts. Okay, we're going to go find Z star. So again, we're looking at a 99% confidence interval. That leaves me 1% to split. So that is 0.005, 0.005. And again, I can't do an inverse T if I don't know the degree of freedom, and that's what they're asking me to solve. So I'm going to go ahead and do inverse norm. And if I don't want to do a sign change for the Z star, I'm going to add together 99 and the 0.005 and do 995. And it's going to give me a Z star score in my calculator. Okay, so when I do that, I get 2.576. So that's going to be my next number, 2.576. And then we're going to have a 9 over square root of n. And now we just have this really big, ugly calculator problem again, or algebra problem of getting n by itself. So first thing I'm going to do is I'm going to multiply both sides by square root of n. Okay, that's going to give me 2 times square root of n equals 2.576 times 9. All right, then the next step is, what else could I do? I could, if I want to get n by itself, divide by 2. So now I have square root of n equals 2.576 times 9 all over 2. And then lastly, if I want to get rid of the square root, I could square both sides. And now I would have n is, I'm going to put this back into greater than or equal to, and it would be 2.576 times 9 all over 2 and then squared. So I'm going to get n has to be greater than or equal to the square of 11.592, which is 134.4 people. So I need it to be people. 134 will not be enough, so I have to go above it. So we should sample at least 135 students should be sampled in order to get a margin of error of at most 2 tests. All right, and that's it for this one. Really short today.